How does the ability to analyze PBMN using Raman spectroscopy influence its practical development for real-world applications such as batteries, sensors, catalysts, or electrochromic devices? Why is it important to study not just one version of the material but several under varying synthesis conditions to optimize both performance and reproducibility in industrial or research settings? What does it mean to determine the Raman spectroscopy of an unknown substance, and what is the process involved in measuring or obtaining its Raman spectrum? Could it involve shining a laser on the material and analyzing the scattered light? Can Davis Zerns manufacture solid-state sodium-ion batteries made from seawater in Latvia? What kind of information does a Raman spectrum contain, and how is it related to the unique vibrational modes of the molecules present in the substance? Why are these vibrational modes considered characteristic, and how does each substance produce a unique pattern of Raman peaks that can act like a molecular fingerprint? How are these spectral features used to identify the species of the substance, and what exactly is meant by species in this context? Does it refer to the specific chemical compound, molecular structure, or type of material? Why is it said that identifying the characteristic Raman spectrum is sufficient for determining the identity of the substance? Could it be because no two different compounds have exactly the same set of vibrational frequencies? How are characteristic peaks selected or recognized within a Raman spectrum? Do they correspond to specific bond types, functional groups, or molecular frameworks that are known to produce signals at certain wave numbers? How can a database or reference library of known Raman spectra be used in this identification process? Can the unknown spectrum simply be compared to known patterns to find a match? What happens if two substances have similar Raman features? Are there still enough subtle differences in intensity, peak width, or position to confidently distinguish between them? How does the resolution of the Raman instrument affect the ability to identify these characteristic features accurately, and what role does calibration or laser wavelength play in ensuring the spectral data is reliable? Could environmental factors, sample impurities, or fluorescence interfere with the spectrum, and how are those issues managed to ensure proper identification? Why is Raman spectroscopy especially useful for this kind of identification? Does it offer advantages over other methods like IR, NMR, or mass spectrometry in terms of speed, non-destructiveness, or the ability to analyze samples directly without preparation? How does this method work for solids, liquids, and gases? Does the principle of matching characteristic Raman signals apply across all states of matter?